Yes. Reflection, refraction, angle of incidence, angle of reflection. फैन स्लो रखो, 2 में रखो फैन को. Just revise it quick. Okay, switch off the lights. Ready? Okay, tell me, what are the conditions when I talk about a chapter called as reflection? Two conditions I told you. All lie in the same plane. Okay, so that is what we have seen it. Then we have seen yesterday mirror, types of mirror, right? Concave mirror and convex mirror. Okay, then after that we have also seen the ray diagrams, different ray diagrams. What is the meaning of P, full form of P? Pole. What is C? Okay, what is F? What is the formula for F? R by 2. So R stands for radius of curvature. Okay, then we have seen different ray diagrams of concave mirror, convex mirror, plane mirror. We have seen the distance between the image and the object, how it is. Then we have seen an important phenomenon that is called as refraction. Yes or no? When a light is entering from a rarer medium to the denser medium, the light will always turn towards normal. We have seen this, right? It will always turn towards normal. Then we have also seen when the light is going from a denser medium to the rarer medium, the light will bend towards like away from normal. Okay, so these are the two conditions that you have to keep in mind, and we have done a quiz yesterday. Chalo, so okay, now look at this. Refraction of light. You have incident ray, blue color dotted line is normal. Okay, PQ, the pink color line is you have incident ray. Then you have seen the rare medium, that is air, glass is the denser medium, and you can see the black ray, that is QR. Okay, can you see QR? So QR is nothing but the reflected ray. So it is bending towards normal. So air is a rarer medium, matlab it is light in weight, and glass is the denser medium. Okay, so look at this now. Laws of refraction. The incident ray, the refracted ray, and the normal to the interface of two transparent media of the point of incidence all lie in the same planes. Look at this. This is incident ray, this is normal, okay, and they all lie in the same plane. Do you all understand? Yes. So same rule was there for the reflection also. Correct or not? Okay, fine. Next, second, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant, and this is called as what? Snell's law. Sine I by sine R is always a constant. Okay, so this is one thing you have to keep in mind. Next, see, this is what the Snell's law, very important. So from here onwards, you will study basic physics in detail, Snell's law. Then there is a chapter called as Hooke's law, Young's modulus, right? Okay, Young's modulus मतलब क्या होता है? वो सब है definition with the graph. Look at this now. Sin I by sin R. Always remember, sin I by sin R will be a constant, and this constant matlab number, कुछ number आएगा 1, 1.52, okay, 1.3. This is called as refractive index. What is this here? So air has a refractive index, glass has a refractive index. Okay, like this, many materials will have refractive index. Higher the refractive index, the light will bend more. You all understand? Less the refractive index, the light will bend less. Do you understand? Okay, so now let us take an example of ice. Now here you have normal, you have incident ray, the light is bending. So the refractive index of ice is how much? 1.31. Okay, 1.31. Next, diamond. Suppose if I park, this is a normal, this dotted line is for my experiment analysis. I take a normal incident ray. Look at this, how much the light is bending, yes or no? So now if I take sin I by sin r, how much I get? Okay, 2.42. So diamond has the highest refractive index. Do you all understand? Now, in NCRT textbooks, they have given a chart. Those are preparing for UPSC examination. In NCRT textbook, they have given a chart of like ice, then water. Okay, like this, they have given a long list of the refractive index. So you should know all these values. Okay, you should know all these values by heart, because in exam they will ask you which material will have more refractive index, less refractive index. So tell me, what is this here? Diamond. And what is this here? Ice. Okay, so take down this constant values, write down these definitions and these two refractive index values quickly. Yeah. Have you written Snell's law? Sin I by sin R, and then you have refractive index of ice, water, diamond, etc. हो गया? चलो, we'll move. जल्दी जल्दी लिखना है, बहुत पढ़ना है अभी. Ready? Look at this now. This is a beaker. There is a pencil, and now this beaker has no water. But now, imagine the first observation here I am making is that without water. Now the second instance, I am filling this beaker with water, and if I watch this pencil now, the pencil appears to be bent. Why? Because of refraction, right? This is a phenomenon. So now look at this. Apparent position, actual position. Okay, look at the apparent position, and now this is the actual position. Okay, so this is what happens here. Refractive index, incident ray, refracted ray, normal, refraction angle. This is medium 1. Look at this, medium 1 and medium 2. What is medium 1? Air. And what is medium 2? Okay, which is light in weight? So air is called as rarer medium. Whatever is light, जो हल्का है, जो पतला है, उसको हम क्या बोलेंगे? Rarer medium. And whatever is heavy, that will be called as denser. Okay, denser medium. Medium 1 and medium 2. We know that sin I by sin R is equal to constant, or it is called as refractive index. So I take it as n. Now look at this. N to 1. Okay, N to 1. Matlab second medium to the first medium. I am comparing what? Second medium to the first medium. So look at this. What is the refractive index of 1? Air. 1. Medium 1 is what? Air. So now refractive index, that is V by 1, and now the second one. You have to take V2. Okay? So now what happens? N12, this will be V2 by V1. Okay? So now if you take the, this is the reciprocal, one and the same, you get 1 by n 1 2. Okay? So how to calculate the refractive index? That is what we are watching now. Absolute refractive index of some material media. Okay, the first medium is vacuum. Imagine vacuum and air. I am taking given example. This is air and this is vacuum. So how to find the refractive index? This is normal. This is incident ray. It will bend towards normal. So absolute refractive index of air is 1.0003. Okay. Next, vacuum and ice. There is a normal. I'm passing a light. It bends. So what is the refractive index of vacuum? Yes. Now refractive index of ice is 1.31. Okay, this is calculation. आपके lab में करेंगे ये सब. Just remember this now. Vacuum and water 1.33. Okay, next, glass 1.52. Okay, next, rock salt 1.54. Next, how much? 2.42. So who has the maximum refractive index? So diamond will bend light the maximum. Okay. So conclusion, refractive index increases, the bending of capacity increases. Okay. These are all problems, need not solve this. Okay, ये बाद में करेंगे हम. Okay, now देखो ये है formula. You have to remember some points. The first point is, if the first medium is not mentioned, take medium as air. If the first medium is vacuum, then the refractive index of the second medium is called as absolute refractive index, and the speed of the light is what? 3 into 10 to the power of 8 meter per second. And look at this, the most important point is the last one, which is given in the box. Refractive index has no units. Okay, it has no units. Okay, these are all questions, we'll do it later. Okay, not today. First we'll do the theory part, and together we'll do the problems. Okay, so now we have seen yesterday about mirror, but now we'll see what? Lens. Look at this. Contact lens, spectacles, magnifying glass, binoculars, microscope, telescope. Who invented telescope? Answer. Yes, Galileo. Next, look at this. A lens is a transparent medium bound by two surfaces. So left side you can see, okay, it is made up of two surfaces. Okay, if I cut it, one is plane and one is like this. This is called as convex and this is called as concave lens. Okay, biconcave. Imagine this is earth, spherical shape. Okay, we have two types of lens, converging and diverging. Yesterday we have seen two types of mirror. What is that? Concave and convex, but I told you converging and diverging. Okay, remember this now. So this mirror here, sorry, this lens is called as converging lens. It looks like this. The white line which is coming, this is called as the incident light. It converges at a point. Okay, it converges, meet at a point. So this is called as the real focus. Now look at this diverging. I'll give you time to draw, don't draw it now. Next you have diverging. The incident light is coming and falling on the concave surface, and if I extend this line, it meets at this point. This is called as virtual focus. Okay, so converging lens and diverging lens. So here you have con means a curve, vex means towards. Okay, con means a curve, cave means inwards. Okay, remember this. Distinguish between convex and concave lens. So we'll first try to understand. Convex has two spherical surfaces curved outwards. Now here this will be inwards. Okay, next it is converging lens, it is diverging lens. Okay, next it forms a real focus, it forms a virtual focus. It is thick in the center and thin at the edges. It is thin in the center and thick at the edges. That's it. Definition they don't ask in exam, but in board exams they will ask you. Common terms used in the lens. The first one, okay, this is the spherical one. See, this is the convex lens. I draw an imaginary circle. Look at number 1. I am drawing an imaginary circle. Number 2, I am drawing imaginary circle 2. So this is called a spherical 1 and spherical 2. Okay. And this dot is called a center of curvature. Okay, this is C1 and this is C2. Okay, now look at this. If I draw a diagram, center of curvature, the center of the sphere whose parts form surfaces of the lens are called as what? Tell me what? Center of curvature. So what is C1, C2 here? Good. Center of curvature. Next, what is R1? C1, radius of curvature. So R1, R2 is radius of curvature. Next, R1, R2. So look at this. Concavo or convex lens. So imagine there is a sphere, positive meniscus, convexo concavo lens, negative meniscus. Principal axis, the imaginary line passing through both the centers. Can you see this white line which I am drawing now? This is the imaginary line passing through both the center of curvature. This is called as principal axis. Optical center. What is the meaning of optical center? Imagine if I am drawing a lens now here, and this center, look at this principal axis, and the center which I am drawing here, this is called as optical center. Did you all understand? Optical center. See this now. A ray of light is passing through the optical center. The red dot there. Okay, so all the deviation will start taking place from that optical center. Okay, next. Principal focus for convex lens. First we'll study about the convex lens. What is this here? Converging or diverging? Tell loudly. After this class gets over, I think it will get over in 15-20 minutes, and then I will show you the UPSC question paper, how they have asked from this chapter of light. Okay? And I want answers from all. Look at this. This is the center of curvature, center, right? Optical center. These yellow lines are the incident light, and it is converging at a point that is f1 focus. Okay, so when light rays parallel to the principal axis are incident on a convex lens, they converge to a point on a principal axis. This point is called as focal. Yes, focus. Then you have f1 and f2. Suppose if the light rays are passing from the right direction. Next, for concave lens. For concave lens, the focus will be in the same side of the light, like this. For concave, it will be f1 here and f2 here. Did you all understand? So difference between convex lens and concave lens. So we have real focus and then you have virtual focus. Focal length, the distance between f1 and f2 is called as what? Focal length. So this is f1. Okay, this is the focal length. Do you all understand? That's it. We have done with the basics. Now look at this now. Look at this carefully. What is happening? Okay, I'm trying to watch a tree with the help of a lens. Look at this. The tree looks inverted. Next, I'm trying to watch a mountain, but it is inverted. Okay, so lens showing a diminished and inverted image. But at what distance is it formed? That is the question. Now ray diagram, basic diagram. Okay, the first I'm going to draw O. This is called as optic center. Yes or no? Then I'll draw a lens like this is called as converging lens, or you can say convex lens. Okay, F1 is the focus. 2F1 is another focus. And now here, these are the main things that I'm going to draw. Now I'm going to take the object. Rules for making the ray diagram. Rule number 1. When the incident ray is parallel to the principal axis, the refracted ray passes through the principal focus. Imagine this is the diagram and this is the incident ray. Look at this now carefully. Incident ray. So what is the observation in the first rule? The refracted ray passes through the principal focus. That means if this is the incident ray, the refracted ray will pass through what? Focus. समझ में आया सभी को? Okay. Next, this is the first rule. Rule number 2. When the incident ray passes through the principal focus, the refracted ray is parallel to the principal axis. That means like this. Imagine if the incident light is passing through the focus, principal main focus, it will be parallel to the principal axis. The refracted ray will be parallel to the principal axis. Rule number 3. When the incident ray passes through the optical center, it passes through changing its direction. Imagine, okay, now it is passing through what? Optical center. And what happens now? Passes without changing its direction. That means it goes straight. So did you all understand? What is the first rule? Tell me. If the incident ray is parallel to principal axis, the refracted ray will pass through the principal focus. If the incident ray is passing from the principal focus, the refracted ray will be parallel to principal axis. And the third incidence, if it passes through optical center, it will be going straight. Correct? Okay, next. Now let us try to understand. So this is how the diagram looks like every time. Incident ray, okay, parallel to the axis. passing through the focus. Second incident ray passing through the F1 parallel to principal axis. Third, it is passing through the optic center. It goes in the same direction. Do you all understand? Okay, so this is one observation. Next, now we have to draw ray diagrams here. Okay, look at this. Object beyond 2f1. Now I am going to draw the ray diagram. So here, this is the ray diagram here. Imagine this is f1, this is 2f1, this is f2, this is 2f2. So where I am going to keep the object now? Beyond 2f1. Okay, that means AB. Can you see the object? Beyond 2f1. So what happens if I draw an axis, a line which is parallel to the principal axis, incident ray? What will happen? The refracted ray will pass from what? F2. Yes or no? Second observation. If the light is passing from the center, what will happen? It will be going in the same direction. Next, third. Okay. Now what happens? Can you see this purple color and the blue color line are intersecting here? It is intersecting below the principal axis or above the principal axis? Okay, so when it is intersecting here below the principal axis, the image will be down, inverted. That is why the tree was inverted. Do you understand? I tried to watch a tree, but it was inverted because of these regions. Okay, so the object will be inverted. So what is your observation here now? Look at this. Position of the image between what? This is F2, this is 2F2. So where is the image between F2 and 2F2? Next, nature of the image, real, inverted, okay, and smaller. Next, object at 2F1. I'm going to keep the object at 2F1. AB is an object. Now if I draw a straight line, incident ray parallel to the principal axis, it will pass through what? F2. Another line passing through the optical center, it will pass through, okay, like this. Now tell me, these two lines are intersecting. Can I join red dot and yellow dot? So what I get, the object is real, inverted, and what size? Same size. Okay, so this is the idea. A dash B dash. Your observation is the object image is at 2F2. Nature of the image is real. It is inverted and what? Same size. So, okay, now third observation between F1 and 2F1. Okay, now look at this. AB I am keeping here. Okay, now I am drawing a straight line parallel to principal axis. It is going like this. Second line going like this, intersecting here. So now here what happens if the line is below the principal axis? The image is inverted. What is image? Inverted. What about the size? Enlarged. Okay, but it is